Hey, good evening, everyone. It works. Surprise. All right, thanks, Tracy. There's a lot of you sitting and standing in the back, but there's a lot of chairs here and here. So if you don't mind, actually, if you guys are up here, if you scoot in, so new people can kind of scoot down. Even though most of you are Wiseliners in the back, please feel free to come and sit down.
Yeah, you see, like the display, so people get excited.
All right, everybody have their pizza, have their beer. At least this guy has his beer. All right, you're good to go. He's got some water there. Okay, so everybody good? Yeah? All right. Welcome to Wiseline Academy. My name is Wendy Johansson. I'm one of the co-founders of Wiseline, and I run Wiseline Academy, which is what we do here. So how many of you have been to a Wiseline Academy talk or course before? I certainly have. Well, all right. Let's try this. How many of you haven't? Welcome. So pleased to have you for the first time. That's fantastic. So I don't know if many of you know, but this week is National Cybersecurity Week, and I think in Mexico City, very, very excited. In Mexico City, they're hosting the 3rd annual cybersecurity conference, and this year, just I believe today's the 13th? Yeah? Okay, so 14th, okay, just yesterday on the 13th then, they actually announced the strategy for cybersecurity in Mexico. So we'll share that link with you later. It's humorously a PDF that you download off their website, totally secure, so that you can read about this strategy that they're going to apply nationwide and make Mexico more cyber secure. So without further ado, I'd love to introduce Martin Vigo, who's coming from San Francisco and everywhere. He works at Salesforce as a senior product security engineer, and we're incredibly lucky to have him come talk to us about web and mobile security standards. So warm welcome for Martin.
Thank you, thank you. All right, first of all, it's so cool to see that there is people that is here for the first time. That means you care about security or free beer. I'm not sure which one of both, but the important thing is you guys are here. We're gonna talk about security. How many of you guys are not engineers, actually? So can I ask which field you are? Are sales or sales? Nice, nice, I love that. Not just programmers. Well, I guess UX is still programmer, but I like to see sales. So it's very interesting that, and very important that people actually cares about security. It's not just about developers, but also to know what you're exposed to when you use the internet, right? So my name is Martin Vigo. This is me with my very first computer when I was 9 years old, and I did La Comunión. It was the best present I got. It was an Amstrad CPC, 6,128 kilobytes. Ow! Really, really badass. I could play a lot of video games, and it was the first time I programmed something which was in BASIC. I was drawing circles, and they even blink, so that was really, really cool. At least I thought so at the time. I'm a senior product security engineer at Salesforce. At Salesforce, I do web, mobile, and authentication. I really like to do research, security-related research on the side. I do bug bounties to make some money, and I drink gin and tonics while I do that. So it's a lot of fun. So let's jump directly in because we have a lot to cover and we don't have a lot of time. But the first slide that I thought I wanted to bring up is how many of you are actually familiar with the OWASP, with the OWASP Top 10? Nice, a lot of you guys. So for the ones that don't know about it, it's basically a non-profit organization that, among other things, does something very cool, which is every few years publishes a top 10 of the most common vulnerabilities in different environments. In this case, we are looking here at the web. So what you see on the left is actually the one from 2013. What you see on my right is 2013. What you see on my left is 2017. It's still a release candidate because there was actually, if you go read about it, there was a lot of heat because they added some in the top 10 that people was not very happy about, specifically something about adding protections like web-based firewalls and stuff like that. And there was a controversy that some of the sponsors were actually selling those products. So this is a release candidate, not yet final, but it's, in my opinion, at least much better than the first draft. So one of the things that you can see here is that most of the vulnerabilities in 2013 are still present today, which is not, we are doing something wrong from the moment we know there is issues, especially when we look at the upper side, and we still have them 5 years later. 5 years in computer science, you guys know that's like 50 years in any other industry, right? So we should do better, and it's important to be familiar with this, and especially because it's the top 10 vulnerabilities. So today we don't have time to cover all of them, and also some of them, especially in 2017, I didn't think it was really important to talk about because they are not vulnerabilities per se. For example, you see using components with known vulnerabilities. That, for example, relates to using third-party libraries that are vulnerable, like imagine an old version of jQuery, for example, for the UX people. So, but that's not specific vulnerabilities. I'm here to tell you guys about specific vulnerabilities and how to defend against them. For me, it's very important that first, you get excited. That's very, very important. Second, you understand the technicality of it. And third, how you can do to actually be a better coder and protect your web apps from them. So another thing that I wanted to mention is this, the top 10 that I showed you is actually for web, but there is a lot of in common with mobile. So a lot of the things that you're gonna learn today totally applies to mobile apps. And what you see here in the background is there is actually 3 types of mobile apps, right? We have the fully native apps, which is basically written in the OS-specific programming language like iOS or Android or Java. And the advantage is that they take full advantage of the capabilities, sensors, you have access to pictures and things like that. On the other end, you have the full web apps, which is they are written in HTML5, JavaScript, CSS, and they have a native wrapper around it, but it's really a web app. And then we have the hybrid apps. Who has used Cordova or PhoneGap here? Cool. So this is basically like a native bridge between the web and the native part. So you get the best of both worlds. You don't need a specific developers for every platform, but you still get the capabilities, the full capabilities of the mobile device. Now, how does this apply to vulnerabilities? Why I'm talking about this? Because if we look at the top 10 mobile vulnerabilities of OWASP, and specifically this is from 2016, we see, and I got really lazy as you can see with the arrows, it gets a little better, the slides, but you see a lot of them are common actually, and that's because even if you have obviously if you have a web app or a hybrid app, all that is web applies to it because you have a web view, right? Cross-site scripting is going to apply, CSRF, all that kind of stuff. But even in fully native apps, you still have APIs that you call that maybe insecure. You still communicate over encrypted or not channel, right? So all those things still apply. You may have even bad crypto. So what we are going to learn today is specific to web, but it also applies to mobile. Specific to web, I mean, we are looking at the OWASP top 10 for web. Beautiful. Without further view, we jump into the injection, and that's the top one in 2017 of the OWASP top 10, okay? Cool. Now, I thought I want to get you guys excited, as I talked about. And the first thing to get you guys excited is to have free beer. So we got the check there. The second is free pizza. We got the check. But there is nothing yet that I did. So I wrote the swag here. So we have T-shirts. We have camera covers, a lot of malware there. So you don't want to do your thing and the camera will be pointing at you. We have RFID blockers, so shields for your badge. This is very handy. Well, I don't have my badge now, but our red team actually took advantage of this at some point. So very cool. And yeah, so a lot of swag. And I want this to be, I want you guys to participate. If not, you're going to fall asleep. I have a funny accent when I speak English, but still, you know, it's going to be a long time. It can get hot here. So what I do to excite you as well is to tell you, before I speak about a specific vulnerability, about a real case scenario in which that vulnerability caused damage. In this case, we are talking about injection attacks, and this is true. An attacker is was able to execute arbitrary code in Flickr. Who uses Flickr? I don't know if that's a thing still. Okay. So he was able to execute arbitrary code on Flickr servers by just sending post requests. Pretty bad, right? So how did it happen? Who has heard about SQL injection? Heard. Nice. You see how I keep exercising you? Making you exercise? That's good. That's good. Glad you guys showered today. So how does this work? So this relates obviously to databases, right? And here you see the example. Imagine like Flickr or any other website in which you log in, right? I put a very clear example here. So what will happen, you guys as developers are familiar with this, you will make a post request in which you send your username and your password for authentication, right? So you may have on your website, on the back end, sorry, a logic something like this. You dynamically construct a SQL query by adding the values of those parameters that came through the post request. And then you query your database, you see if the user exists, you see if the password matches. In reality, this is a simplified version. I hope that you are hashing your passwords. We'll go to that. But and then you return a session cookie. So it's too bad the colors are not the best. I should have thought about that. But what you have here is how you programmatically do that query. And what you have at the bottom, what I put is what the query turns into when you feed those two values, which are the parameters. And we have a select star from users where username equals admin and password equals query, QWERTY. Awesome. So what happens if I log in as an attacker and instead of my username, I put, and this is important, Priscilla, how do you say this one? Single quote, thank you. I got a lot of translators today, that's awesome. Or 1 equals 1. What is this or 1 equals 1? Well, 1 equals 1 always translates to true. So whatever you have before that, because you have an or true, that's always gonna be true. So, and this is a very simple SQL injection example, but at the same time, it's the first thing you do to try this. And when we look how it translates down, we see that it says select star from users where username equals, and I painted it in red, the first quote, because that's what you have also here, you see, because you are using the single quotes to construct your query. So that's why I'm adding this one extra, because there I close the string. So I'm saying username equals quote, quote. So equals nothing, that will be false, or 1 equals 1, true, and password equals nothing. It doesn't matter because, yeah. Oh yeah, this is so much better now. And it's a little like trippy, right? I was at Burning Man once and I was seeing the same colors, so I thought it would motivate you. So anyway, so what we have here is a true sentence. This will return the first query of your table, the first row of the table users, which sometimes is admin, but you don't care because it returns true and you will get a valid session. So with examples like this, such basic thing as using as a username this, you will alter the query in a way that it will return true and you will get a valid session, hence you can log in. So there is actually much more to it. It's not usually that simple, right? Especially as the time passes. But there is really, really fancy attacks. For example, you may want to start by knowing the version of the database because there may be available public exploits for it, or you at least want to know what kind of syntax you want to use to know if it's a Oracle database or if it's a MySQL database or MariaDB or anything like that, because that is what's going to change your payloads, right? There is something really cool that is blind SQL injection, because when I give the example of the logging in, you can see the response and see if it worked or not. But sometimes when we do advanced attacks, you cannot see your response, or the response is just the same. So you need to use other tricks to basically get to a state in which it's true or false. And you can do things like trial and error, like for example, you want to see if the user with ID 5 exists, and you give it a true condition, and then you give it a false condition, and then you see if something changes, and you can start to play with that. Even nicer are timing attacks. When you cannot see a response, instead of me saying, oh, I'm going to log in with this and it doesn't work, I can add an expensive mathematical operation in addition. So I will say, if user is Martin, then multiply 2 primes that are very big. So if I see that it takes 10 seconds to respond, I got my true condition that exists, even though I cannot really see that the username comes back in the response. But I know because of the timing attack. So these are very clever side channels attacks. It's very cool. then you can actually, it's not just about logging in, you can cause much more damage with file upload, which can lead to remote code execution just with SQL injection. This is an example. You will add an additional query with a union. And then, for example, in this case, what you do is you create a file with a payload that usually is called a web shell. For example, in PHP, you can just say, hey, any commands that comes as part of the URL, interpret it as code. And then if you are able to put that file in a word-readable folder on the web server, you can then in the URL go there and pass as parameter your commands, and suddenly you have a shell. So that's pretty awesome. And there is much more. Now, imagine, because, for example, timing attacks, very common. Like, you want to find out the names of the tables. So you say, hey, if there is a table that starts with T, wait 5 seconds, and it doesn't wait. If it starts with A, wait 5 seconds, it doesn't. If it starts with B, oh, it waited 5 seconds. So if it starts with BA, with BB, with BC, you can start to brute force actually table names, so then you can later query, for example, looking for credit cards or stuff like that. So, but doing that manually, it's really, really difficult. So SQL Map is an awesome tool that comes with everything already there. So when we do SQL injection, things that you try is just to put a single quote, and actually this is true. I think it was the healthcare.gov website. The most searched, like in Google, the most searched term was a single quote, because it was so vulnerable, that site, made by the government that cost millions, that everyone was doing SQL injection. That was the single most searched term, a single quote, because what you will get is an error. If I add just a single quote, I didn't terminate the string, and it breaks and it returns an error. So anyway, SQL Map is there to help you if you find that it's possible to have a SQL injection, and it has a huge list of payloads for every single database. It's command-based, so instead of you having to know all these tricky queries, you just say, hey, this is a whatever database, I want the usernames, look if there is this table. It's really, really awesome. And of course, there are other types of injection attacks, but this is one that is the most common. You can do injection attacks on LDAP or OS commands. Very common to do a semicolon, because you are basically feeding into a bash whatever the user is passing. So you do semicolon, and then you can append a new command. So that is pretty good, pretty easy technique. And some other protocols. So now we got to learn how to protect us. So most single important thing, and it applies to everything, all user input is bad, it's malicious, you don't want it. So always consider that anything that comes from the user is bad, and act accordingly. Use parameterized queries. That's the most important thing. So instead of constructing dynamically your queries as a concatenating strings with values, you want to use what is called parameterized queries, which you will basically, and I put an example here for Java, which you actually cast the values that you want. So you are actually also sanitizing and validating. You are actually doing a little bit of whitelist here, because you are only accepting strings. So this is the most important thing to do. And all the ORM libraries and all that stuff will do that for you. But it's very important that you don't construct your libraries by just concatenating strings and values. Escaping. Single quotes, as I said, is the single most dangerous thing. So you can do escaping too. You can do pattern check hit lists. I forgot this to separate it. But basically, man, if you have a field that is a phone number, why would you accept letters, right? So you can. It's just all about adding layers of security, because you may have an injection attack, but because you added like whitelists or you added pattern checks, it's still not going to go through. So that's good. No one can be fully secure, but you can make it very difficult for it to be exploitable. Whitelist I mentioned already, and also protect the infrastructure. The database should be running with a user that is as low privilege as possible, because if I get command execution but I cannot write a file anywhere, then if I can upload files but I cannot run them, or I just cannot write them anywhere because the user doesn't have those rights, then I may have injection attacks, but I cannot really do much with it. And the DB, maybe sometimes it's better that it sits on a different environment. So if that environment gets compromised, at least he cannot talk back to where the web server is running. So this is really cool. So this is a legit example. So this guy, and you can go read about it, he did SQL injection to the traffic lights when he was speeding. And you can totally tell that he puts his traffic light, he had this because he knew there was 2 more columns there. But then he does the semicolon drop database. So he deleted all the basically other people from the database that actually break the law by speeding. This is really, really epic. And think about it, the camera is processing license plates. So he's gonna process this. And this comes to, again, like that we don't protect all the environments, just the ones that we think can be exposed. Who would have thought that someone is gonna do this, right? This is pretty, pretty awesome. All right, so how does this happen? I want to come back to this now that we understand the SQL injection. So this happened just basically what we explained. This guy found that SQL injection, so what he did, he uploaded a PHP file that was a web shell, and then he used that to execute commands on Flickr and was able to have remote code execution. He got $15,000 for that. All right, ready for the next one? All right, sensitive data exposure. I think it's the number 2 in the OWASP Top 10 2017. Let's start. LastPass, who uses LastPass here? Okay, don't be shy, now you know what's coming, come on. It's okay, I don't know your email, it's okay. All right, so LastPass is a very popular cloud-based password manager. So you shouldn't be reusing your passwords. So what you do is you have them in a vault that is encrypted with your very, very secure single password, and that's a good thing. So LastPass is a password manager that encrypts all your passwords and claims zero knowledge. Zero knowledge, as in NSA comes tomorrow, owns their servers, and theoretically they don't know anything because everything happens on the client side and all they have is encrypted data of you. Yet an attacker is able to look at encrypted data and obtain clear text passwords. Now, I forgot to do this before, but how do you guys think that happened for one shirt? No, that's you know what, it's an excellent guess. And the reason is because they use a Chrome plugin or a browser plugin, sorry, which is JavaScript. So with JavaScript, you can do a lot of stuff. So that could have been possible. But if you look in this case, I'm talking about looking at encrypted data and being able to obtain clear text passwords. But how would you decrypt the passwords? No SSL certificate, no, they use cert pinning. No, no man in the middle, no client side. Okay, so I'm gonna throw it there and we get into it. I wanna see fights here, okay? More beer for these people. All right, so look at this. So crypto is something that is really hard to do. And I took this example. I went to the Whitelisting and took an image, right? And this is very popular image with the Linux tax symbol, but I wanted to do it cool and to do it with Whitelisting. So you have the picture on top, and on the next one, what you see is encrypted by NIST recommended crypto suite, which is AES. Probably you guys have heard about AES, and it's very cool. But if you zoom into it, you can totally see the logo. Would you encrypt like the Snowden documents like this? Probably not, right? You wouldn't encrypt anything like this, even though it's using AES, but it's using AES in ECB mode, and we'll talk about that. Now, this is the same image with CBC mode. This looks encrypted. Encryption is to get confidentiality. I think we can agree there is no confidentiality here, but there is a lot of confidentiality here. So what happened there? So again, cryptography is hard. Even, I mean, if you don't have any cryptography, that's bad. But even if you have cryptography, there is still a lot of ways to mess up. So first of all, encoding is not encryption. Encoding is a different way of representing data, but it doesn't offer confidentiality. Encryption does. there is many multiple multiple crypto algorithms, and many of them are already broken because with the academia and computers being more powerful, it just happens, and that's okay, because as long as we are ahead of the game, we just come up, well, not we, I wish I was a crypto guru, but there is very smart people out there that comes up with new algorithms that are reviewed by the community, and they are accepted and are public knowledge, and which is, you don't want security through obscurity, so they are all good. But even if you have that, again, like AES, it may be still tricky to implement securely. If you have the strongest crypto algorithm, but you have a key that is very weak, you use your password as a key, you still are going to be able to decrypt it. Or if you have global keys, that's a bad practice, because if Wiseline uses the same encryption key to encrypt everything, and I compromise one single machine, I can decrypt everything. So you want per user crypto keys or per environments or anything like that. Or just using null IVs, which relates to ECB and CBC. Null IVs prevent, and this is what the image is about, prevent that the same clear text results in the same ciphertext. And this is what is happening here. If you look, I encrypted every single pixel with ECB. ECB is a crypto mode that the same clear text results in the same ciphertext. That means the same color of that pixel results in the same color when it's encrypted. So it's not good for files, for images, because you have a lot of common data in that file. And so this ECB mode can be used in certain cases, but the best thing is just to stay away from it. And again, you will be using a crypto algorithm that is approved, but in a mode that is insecure, specifically for the case of files and images. And again, there is also very advanced attacks that are insecure, using insecure pseudo-random generators to generate your encryption key or just your entropy. So that's the case. So what happens with the ECB mode is exactly what I said. Basically, the same clear text results in the same ciphertext. So let's talk a little bit different, but still about data leakage. And in this case, password storage. You don't want to store passwords in clear text. That's pretty obvious because it's insecure. You don't want to store passwords encrypted because it's an unnecessary risk, and it's a problem with privacy because there is no need for you to know the password. You just need to verify that the password is the one that he input, and for that we have things like hash functions, which, as you probably all know, it's a one-way operation. That means from clear text you can get to a hash, to not a random value, but to a value that is deterministic. But it's computationally very, very expensive to come from that value back to clear text. So you can totally, when you log in, just hash the value that the user passed you and compare the two both hash values. If they are the same, then you know the password is correct. Now, that's still not enough because there is a lot of efforts by the community to calculate those hashes, and they created what is called rainbow tables. So basically, if you use something like MD5, which is also bad because it's broken, if someone already calculated the top 1,000 passwords, I only have to go and compare because I already know the hash value for those 1,000 passwords, and I see the hash value, I know automatically the clear text password. So what you want to use is what is called a salt. A salt is not meant to be secret, it's just meant to be random. And what you do is you take the password and you append a random string to it. What it does is that now the password is not really the password that the user used, but it's the password plus a random thing. So the rainbow tables won't work anymore because the password is different than the common 1,000 passwords or 10,000 passwords that usually hackers use to crack this. And then salted hashes still don't solve the brute force protection, because I could still try and go to brute force nowadays with distributed AWS machines and crypto and hashing functions like MD5 that uses a low key length. You could still be able to brute force us. So the additional step that you can do is use what is called key derivation functions. Key derivation functions, what they create is from an input that is usually the password and a salt. They basically, if you take that they do the salt of SHA-256, they will do that SHA-256 100,000 times. So now When someone logs in, instead of a nanosecond, it will take maybe half a second to calculate that. But when someone wants to brute force that, he needs to brute force the million passwords, paying the penalty of half a second instead of a nanosecond. So this is why, and this is specifically PBKDF2, but there are others that are expensive in memory, like scrypt or bcrypt. So you want to use these two to store your passwords. So one thing more for data leakage. Insecure communication. This is how your client talks to your server. Who has used HTTP before? Anyone that uses web? So you guys still awake, I like that. So HTTP, clear text protocol, offers no confidentiality, offers no integrity, and offers no identification. You don't know the server, you can't identify the server you are talking to, you cannot make sure that no one tampered with the traffic, and you cannot make sure that your traffic stays secret. So you want to use HTTPS, which is there is a huge effort now with things like Let's Encrypt to give free certificates so the internet becomes encrypted world. But still you can mess up. Well, not that you can mess up, it still can be insecure just by using HTTPS. There is a lot of weak cipher suits like SSL3 or TLS 1.0, and again, very smart people come with attacks like the Poodle or Beast or Lucky 13. You can go read about this, but it basically is able to decrypt that traffic with side channels attacks based on compression and other things that are very fancy. You may have HTTPS, but you are not enforcing it. Who has heard about HSTS? Cool. HSTS is a header that you can serve in your response that tells the browser only to use HTTPS with that server. So Whitelisting responds to the first query with a HSTS header saying, hey, from now on, you are only going to talk to me over HTTPS. And this is very important, and it came out because of an attack that is SSL strip, and there is a tool very easy to use. You guys should go play with it. What does it do? Very, very simple. I have a man in the middle between you and the server, right? That is something that is pretty easy to do if you are on the same Wi-Fi or if we are both having a coffee at Starbucks. So when you go to connect to Facebook, I cannot see your traffic, but I can send you packets. So what I could do is I could tell you when you connect to Facebook that I am Facebook and that I only support HTTP. Now, Facebook only supports HTTPS, so I get your traffic, and then I do whatever I want, look at it, tamper with it, and then I initiate a connection to Facebook saying, hey, and I encrypt it with a Facebook certificate. So this is basically a downgrade attack. I'm telling the client that I only support HTTP, and then I'm telling Facebook that it's okay to use HTTPS, but I'm in the middle and I can see the encrypted traffic. So this is why HSTS is very important, because when I try to tell you, hey, I only support HTTP, then the browser is going to say, oh, no. I know Facebook only, Whitelisting only accepts HTTPS, so I'm going to drop the connection. So this is very cool. Or we can have mixed content. Mixed content is when you have on a site, it's a site that is HTTPS, it looks very cool, but then you're loading an image over HTTP. Or you're loading, even worse, a JavaScript file over HTTP. So you still see the really nice log, you still see HTTPS and all that nice stuff, but in reality there is traffic going over HTTP. And the worst thing that can happen is the cookies are going to be sent over HTTP as well. So if you are loading from the same domain a JavaScript file or anything, the cookies are being sent, your session cookies. So someone just sitting there is going to be able to see it. Of course, they could also tamper with the JavaScript if you are doing that. So you need, again, to have HTTPS everywhere. And then we can talk about certificates. Do not accept self-signed certificates. You have a number of CAs in your browsers that you trust. It includes some from China. It includes some from Russia, but go figure. And sometimes what we find is that no host validation. So you have encrypted traffic, but I don't really look that you are talking to the host that you are supposed to. Wow, that was a lot of things. So I'm just going to throw some sunglasses out. Okay, just to wait up. You see? Now we got energy. All right. So recommendations, because I want you to pay attention to this. Crypto, only use standards. Don't roll out your own crypto. 128 bits minimum of key length. No global I was like, non-global random? Of course. So use non-global random unique keys. Very, very important. Password storage. Don't store passwords. Store hashes. Don't use MDK5 because it's broken. Don't use SHA-1 because it's deprecated. Google is making a huge effort for that. Salt per user. Salts don't need to be secret, so you can append them next to the password. That's okay. It just makes the passwords very unique. And use key derivation functions, again, to prevent brute force. Communication. Only use HTTPS. Ideally, TLS 1.1 or above. Enforce it. Use HSTS. Use CSP, Content Security Policy. Very important, very new. Only accept trusted signed certificates, and do key pinning if you can, even though Google now is saying it's not that good, and they are saying to use CERT transparency, CA transparency, transparency, I think. So anyway, what happened with LastPass? This is something actually I found. You can read it on my website, the article. So much for self-promotion. So this is very, very, very crazy. But LastPass, what they were doing is they were encrypting your password with ECB, AES ECB. What does it mean? That my passwords, if they are the same, then LastPass, who stores my encrypted vault, can see that passwords are the same. But you could still say, well, I know the passwords are the same, but I don't know the actual password. Now, the problem is when you go to sites like, and you should register there, haveibeenpound.com, which it's this guy that buys and collects all the passwords dumps from hacks that has been done. You can go there, put your email, and it will tell you when your email shows up in one of those. I'm registered, it's legit, it's pretty cool. So what is the problem? I now use a common password. It's encrypted, right? So they don't know. But now I see in a dump, imagine that my Dropbox was hacked and the passwords were dumped, which is true. Now an attacker can see my encrypted password, right? So if I have that same password somewhere else, they only have to look at my encrypted vault, and if in Gmail I use the same password, just by looking at the encrypted traffic, they know it's the same one, so they will be able to log in. So this is a huge mistake by LastPass, because it's leaking information about your passwords, information that can be used for those purposes. All right, and if you guys have questions, it's good to get a little bit of light. That's why I put it around here. If you guys have any questions, feel free to interrupt, okay? So who has heard about XXE? Yep.
What happens if, for example, you use LastPass, your password is just a few characters. Let's suppose I use Hotmail and also Gmail. And I have very similar passwords. Do they look the same or?
Very similar or the same?
Very similar. So a couple of characters different.
It's a very interesting question. You just want a camera cover. Well, it's later for you. Sorry. So very important question, because if you look at how ECB works, it works by blocks. So if you have a password that is password 123 and you have a password that is password 124, they will be able to tell from the beginning of the encrypted cipher text, of the encrypted text, that at least password is the same. So they will be able to leak at least the part of the password is the same, because it doesn't encrypt as a chunk, as an entire thing. It encrypts by blocks. So those blocks will be the same, 16-bit blocks, I think. Yeah.
What makes a good call? I mean, I usually use the random function in the programming language like that.
Mm-hmm.
But I assume that those are common, so people can make it. So what makes me a good call?
So I think the industry standard right now is a fourth of your key length. So for example, 16 bits for 128 bits a key length. But most importantly, they need to be random. They don't need to be a secret, but they need to be random. So use the pseudo-random generator that the operatives, whatever the programming language offers. Secure random for Java or whatever. But don't do your own like pseudo-random generator. It's very important that it's completely random. Cool, XXE guys, XXE. So an attacker is able to make one single GET request to Facebook, this is true again, and obtain the etc password file. How did this happen? RFID batches. So the question is, how an attacker was able with one single GET request to obtain the etc password file from one of Facebook's server. Yep. No, remember we are talking about XXE. It could be a possibility, but that was not the case. With that, it will pop up a window, but you wouldn't really get that. That will be cross-site scripting, I think what you're talking about. We'll get into that. That's not the case here. You guys are obsessed with man in the middle. I love it. So remember, you are attacking Facebook servers, not a user of Facebook. An injection like what? So I'm going to give a hint. We're talking about XML. Yeah, you're close. You're close. Good. Awesome. So let's look into it. So XML, everyone knows about XML probably. It's a markup language. So, but we are interested in knowing what is the DTD. The DTD defines the structure of the XML document. You see it here on the left. I'm saying this XML document is about people and a person. What does a person have? A name, a birthday, a gender, a social security number, and probably a life as well. So on the left side, what you see is that it's loading the DTD from a file. That is telling us that we can store in a file the structure of an XML and then in the XML file load it. This is very important. Now we have the concept of entities, which are pointers to data. This is very useful when you don't want to copy paste the same thing in a lot of files, right? And they can also point externally. You see this here. I want to load a copyright XML, which is like all these terms of service or whatever, imagine, and I don't want to be copy pasting it in all my XML files. So I just load it and I reference to it. Okay, so again, we can store it externally, and this is key. XXE, it targets XML parsers. It was a huge thing 2 years ago, several Black Hat talks, because there was some Java libraries that were vulnerable to this. So, but the truth is, it's caused mostly by misconfiguration. And the problem is not by misconfiguration, but by the libraries being insecure by default. So it wasn't really a vulnerability. It was that by default, it's like I have a house and by default, it comes without doors, right? So anyone can go in and then I gotta go and put the doors on it. So the attacker sends specially crafted XML payloads. Imagine if you do a SOAP request, which is over XML, imagine that you do some single sign-on, which also uses, so you are actually sending XML, so you can change that to add your payloads. And XML parsers are present everywhere. They are to parse PDFs and things like that for images like SVG and EXIF. Configuration files could also be XML. So, or networking protocols are, again, like SOAP or SAML. So web services are running XML parsers. And the problem is that they are insecure by default. So, but what is exactly what you can do with XXE? Well, there's a lot that you can do. This is called the billion last attack, LOL, right? And it's actually very, very interesting because I told you guys that with an entity it's a reference to data, but you can also reference other entities. So this becomes recursive. So what this is doing is that lol9, which is what you print in the end, is referencing 10 times lol8, which at the same time is 10 times lol7. So when your server is trying to actually parse this and put the actual data, which is 10 billions of lols, the server will collapse because the XML parser cannot handle it. So this is a DOS attack. You can do server-side request forgery. We will talk about cross-site request forgery, but this is basically forcing the server to make requests. Why do you care? You can use it to scan the internal network because now you can point it to internal IPs. By the way, JavaScript has a library that tells you the internal IP of a client, which is pretty crazy. You can also use it to actually make a request to your server, and now you have a public IP of a server that you are not supposed to know, that you can go and pen test, right? Instead of just the regular web server. We have remote file read. This is the most single classic one that you try when you have XXE. Because entities are pointers to data, why not point to etc password, right? And then you print it. So when the response comes back, you go and see it. And you can even get to have remote code execution on specific cases. In this case, with the expect handler for PHP. So you could actually force and send commands, which is pretty crazy. And that's, okay, recommendations. Know and audit your XML parsers. That's really what I can tell you guys. This is not about something vulnerable. It's more, you need to know what you have XML parsers, especially that they are parsing user input. User input is malicious, remember. So know and audit them. And there is a really nice cheat sheet because there is a lot of things depending on what programming languages you're using and what libraries. So go check this out. I think we will upload the slides somewhere, so feel free. You don't need to take pictures. But this allows DTD if you can. Do not include external entities. Do not include parameter entities. Do not include external DTDs. Validate and sanitize. Again, if you have a phone number, just accept phone number formats. And that's the cheat sheet. Amazing. So how did this guy do this? You were mentioning it. That's why you won that really nice shirt. Basically, he found that he was an XSS vulnerability. He uploaded a web shell, and he was able to execute it. So that was pretty cool. Okay, cross-site scripting. Now we're talking. Oh, now everyone wants to answer, the question. Okay, Samy Kamkar. Who knows this guy? This guy is incredible. He has a YouTube channel. You should go see it. He built a $10 device that opens any garage in the world in 8 seconds. He teaches you how to do it. He did a small device that opens combination locks from lockers in brute forcing it, but it's actually a mechanical thing, so it's pretty awesome to see. He 3D printed it. He was the one that discovered the attack that is called a super cookie that was leaked in the Snowden documents that the NSA was using it. Pretty cool, this guy. Go and check it out. So Samy Kamkar in 2005 became very famous because he was able to shut down the #1 site in the internet at the time, MySpace. Who had a MySpace account? Oh, okay. Freakies. So he did that by simply updating his profile. Pretty crazy. How did he do that? Camera covers. How did he do that? Awesome. What do you want? You want this ball that changes color? All right, look, it's going to become blue. Awesome. Very similar. We get back to that. Very good. Let's talk about XSS. Okay, so this is HTML. Right? And one of the things you need to understand in HTML is that it's code and there is data. Code here is in red, data is in green. This is what the browser interprets, code and data. So inside HTML, what you have is the tag name, which could be the body or div. You have attribute names, and then you have attribute values, and then you have text content. And when we put that in a browser, you see it says, hello world. Awesome. So, how do I do if I want to set the ID to full double quote bigger than bar? So, I mean, what I will do, I will type on the keyboard, of course, but what will happen? Very good. What do you want from here? Yeah. This one is for you, Priscilla. You manage this. Very good. So what you do is you will close the quote. Remember SQL injection, kind of similar. You close the quote, So now the browser, because it's a reserved character, understands that you are closing the parameter value, and then you are closing the div tag, so the rest is going to be interpreted as data. So you basically broke the HTML. Now, why do we really care about this? Look at Google. I searched for hello world, and the response, when I searched for hello world, when the response came and I looked at the DOM, actually what I entered was in the DOM. So interesting. This means that I can control what Google serves back, right? My input is feed into Google's DOM. This is becoming interesting. Because what if I go to Google and I search for close div, open image, source equal X, which doesn't exist, so on error I alert hacked. Yeah. What does it mean that I get a pop-up? That means that I get JavaScript execution on Google domain. So as you can see on top, I put the exact payload so I could make valid HTML, and now what we have is an image tag which has an invalid URL which will trigger the on-error handler, which is a JavaScript handler. That means what comes inside is actually interpreted by the JavaScript parser. So I have now effectively JavaScript execution on google.com. Nice. So what is XSS? Delivering malicious payloads to trick the browser into interpreting it as code instead of data, allowing an attacker to execute arbitrary JavaScript code in the domain context. And I said here, I said that now. I always wanted to have a quote. So what are the threats? What can you do when you get you are able to pass you are able to basically pass JavaScript code that is going to be executed? Well, you can do session hijacking because you can steal cookies. Document.cookie is this JavaScript way of getting access to the session cookies, or to all the cookies actually. You can do phishing because I could just put JavaScript to alter the UI and put a fake Google page. Data leakage. I can parse the DOM. If you're in Gmail and I have XSS, go over your emails and exfiltrate them to my server by sending AJAX requests. I can abuse HTML5 APIs and access users' geolocation, webcams, microphone, that I don't have anything, and a lot of more stuff, everything that HTML can do. Don't worry, I leave some for the guys behind, I'm sorry. But one of the cool things you can do is you can mine cryptocurrencies. Who has, come on, be honest, who has used the Pirate Bay here? Who has used the Pirate Bay? Okay. They were actually doing that. They were using your computer to mine coins. But the best thing, go checking this out, is the Beef project. The Beef project is a framework who has heard about Metasploit, something very similar. So the only thing you need to add as a payload is including a JavaScript file, and now you hijack the browser and you get all these really cool modules to do all this and much, much more. Go check it out, play with it, it's really awesome. Don't be evil. So what types of XSS do we have? I'm not sure how we are going in time, so let me know. You guys can stop me, but so yeah. I will hurry up a little bit. So there is non-persistent XSS and persistent XSS. Non-persistent XSS means that the attacker actually sends you the malicious payload in a URL, for example, and it will be reflected in the DOM. A clear example is if I send you, hey, you want to go, I send you an email and say, hey, look here at this Google search, and I search for script alert 1 script, right? So the URL will be google.com/search equals interrogation Q from query equals and my payload. So you see a google.com link, that's not bad, and you click on it and boom, I just executed my JavaScript code as you in your context. It's usually delivered as URLs, as I mentioned. There is other ways to send this. It's using for spam campaigns, clickbaits. Who has seen on Facebook, oh, you will never guess how this happened to this guy, in a circle pointing at something weird. And then, have you ever guys seen like friends of you like posting those things? This is because they are clicking on it and someone found an XSS vulnerability, and what they are doing is they try to make it wormable. So part of the payload is reposting it again. And it usually comes obfuscated, like I URL encoded this. So this says script alert hacked. Obviously it doesn't work because Google is not vulnerable to this, but you see this and you just see a legit domain. Or it comes just as URL shorteners. That's another technique that they use. I get tons of those from PayPal. Oh, your account was locked, and you go, I never click, you just hover over it, and it will tell you bit.ly, yeah, sure, right? Persistent XSS, this is the most dangerous one, because this one needs to be sent by the attacker, and it's going to execute when you click on it, and it's gone. Store XSS is stored on the database. Imagine in a forum, I post a message that is JavaScript and is interpreted as such. I post it, and this is stored in the server. Every time someone goes to see this thread, that's going to be rendered, it's going to be executed for everyone. So this is this is the most dangerous one because it will be served to all the clients. I don't have to do anything anymore. How do we fix this? Validation, what would you validate? So how do you whitelist what you can search in Google? I want to be able to search script alert one script. I think Google lets me do that. It's a very good point. I'm just giving you more pressure to think about it. No, it's good because whitelist could be the solution, but the problem is you have places in which you have to allow any input, right? So that's tricky. You cannot use whitelists. Sanitize the input sounds pretty good. So how do you sanitize it? And I need to run because they're going to kick me out. How do you sanitize? Yes, escaping and encoding. Awesome. Be fair and come pick up later some stuff here. I don't know. I remember it was you and you. So encoding and escaping. Encode your HTML special characters. Why? Encoding is what tells the browser that that is data, not code. So you cannot trick the browser anymore. So if you encode your data, for example, the less than, greater than, that tells the browser this is data, no matter what it is in the DOM. But it gets tricky because you need to be aware of the different contexts. And in that, you have to be aware of the different parsers, JavaScript parser, URI parser, HTML parser. And inside that, of the different encodings, the URI encoding is different than the HTML encoding, which is different than the JavaScript encoding. So bottom line, use existing libraries to escape all your inputs, all your user input. Additional layers, use content security policy. If you use this here, it will tell it that it will only accept JavaScript that is loaded from files from your own domain. So anything that I pass on URLs is not going to execute. Serve the XXS protection header, which for all browsers is pretty handy. And protect your session cookie with the HTTP only flag. Wiseline doesn't have it, so you guys should add it. I checked it. so Samy Kamkar, what he did was exactly what he mentioned. He put an XSS payload, but he did something very smart. He made it wormable. So his payload, what he will do, he will add the person that visits his profile as a friend and post, but overall, Samy is my hero. What happened? His girlfriend and a couple of more visited his profile, so now they got the payload. So the friends that visit them also got the payload. In 24 hours, the entire site was down. This is the same as saying that Google, you were able to shut down Google with a search or by modifying your Google Plus profile. He was supposed to go to jail, he pleaded guilty, and he was 3 years not allowed to touch a computer that was connected to the internet. Pretty crazy. Now he's really badass. Go check him out. Do we have time for this? 5 minutes? Oh, I love it. Thank you. I'm very excited. When you're excited about something, I don't get tired. Just hot, but not tired. CSRF, I love this vulnerability, and it's gone from the 2017, which I do back bounties, and I find this all the time, so I'm not sure about this. So this is very cool. Millions of routers fully compromised after victims visited the router's official forum site. How did that happen? Oh, it's still fresh. What? That, if you use shodan.io, which is a Google, no. It's also not man in the middle, by the way. No iframes, but there is very clever attacks with iframes. No, that will be more in the reverse engineering kind of aspect. It's about CSRF. So, well, it's about CSRF. The point is you guys don't know about it, and I want you to think about it. Priscilla? Can you repeat that, please? You deserve an applause. Come on, guys. Yeah, very good. And we'll see what kind of request it forces. Very, very good. So we need to talk about cookies when we talk about CSRF. This is Wiseline cookies. I was not trying to target Wiseline. It's all secure, but you see here, for example, the secure one and the HTTP only one are not there, and this is the session cookie. But it's something, I mean, it's not vulnerable or anything, Wiseline, but it's something nice to have, an additional layer. Point is, what are cookies? Cookies are key value pairs to store data. They became not popular, they were invented when we, especially for the Web 2.0, because it used to be that we had these really cheap websites in GeoCities and all that stuff, but then when it came things like online stores, you had to keep a state. HTTP is a stateless protocol. That means I make a request, and the next one I do, the server doesn't know anymore who am I. So cookies serve as an additional piece of information like a session cookie, which makes it stateful, because now in the next request, I'm also sending a cookie so he knows who am I and can act accordingly, like, for example, in a shopping cart, right? So they are especially used for authentication. Cookies are assigned to domains. As you can see here, it says this cookie that is called JWT. They are using this standard, which is signed thing. It's not really random, but let's think about it as a random string. And cookies are sent on every request based on the domain. Again, so how does a browser work? I go now to wiseline.com, I authenticate, I get a cookie served, which is my session cookie. And now, like later, I do a request. I do another request to wiseline.com, and the browser will put the hand in the cookie jar, look for all the cookies that are assigned to wiseline.com, append them to that request, and send it over. Okay? So the browser is always going to make requests, first look at the cookie jar and get all the cookies out and append them that are for that domain. Very, very important. Consider this fake request example. bankofamerica.com, session cookie right here. Imagine that there is this API, right? This could totally be normal. That the way when you transfer money is a parameter that is from account and your account number to an account and an amount, right? Cool. So what happens if you logged into your Bank of America, you are logged in, or imagine Facebook, but let's keep it on Bank of America. You are always logged in. You don't enter your password all the time, right? Now you come to my malicious site and I have an image which sources that exact request. Imagine I wanted to put here in reality, I mean, I'm not going to know your bank account, but let's figure that I know. Or imagine that the API is your username, right? Just for the purpose of the example. So what will happen? You come to my malicious site, I load in my JavaScript, in my HTML, there is this image. What is the browser going to do? It's going to make a request. Yeah, exactly. So your browser will make this request, will look at the cookie jar, will see the cookies from Bank of America, you are authenticated, it will send, and then boom, you just transfer me $1,000. Wow. So cookies are sent along. Well, okay, I just explained this. This is what happens. When you come and I have that image, it will do that request, try to go to Bank of America to retrieve that image that doesn't really exist, but I don't care. You made me a transfer of money because you sent the cookie along. Your browser sent the cookie along. So what is CSRF? CSRF forces victims to make unsolicited requests. I went to your website. I didn't want to transfer you money, but you forced me to do it because your JavaScript code, you program it that way. targets state-changing requests. This is very important. Why? Because if I do a GET, imagine a RESTful world, right? GET requests are read-only, meaning I get pictures from Facebook and they show up, or I update my profile, so you do a post request because you are changing something, right? Why can I not target the GET requests? Because of same origin policy, if you come to my site and I make you do a GET request, the response is going to come back, but I cannot read it because it comes from a different domain. It's about same origin policy. If you're not familiar with it, it's a basic browser protection, because if not, it will be really bad. I just will load your Gmail and go over the DOM, right? So same origin policy prevents that from one domain I can access data that was requested from another domain. So, but I don't care if I force you to change something. Sure, I made you transfer money. The response is going to be money transfer. I don't care. I don't want to read that. I just want the money. So that's why it targets state changing requests, because the change was already done. I don't care about the response anymore. And takes, of course, advantage of the session cookies. How do we fix this? Is the internet broken? You already got 2 t-shirts and 3 badges.
So you can do both. You have a session and it will expire after 20 times. And the second one is to use a token that will expire after 1 use. And it will require a 2-factor authentication without separate token.
Okay, you know the UX guys are gonna hate you. I work in security, I try to add protection layers. That could work if you force to do 2FA on every request, but let's take, for example, okay, a bank for that will make sense, but a state changing request that is less like sending an email. Sending an email is POS, right? You're not gonna ask for 2FA all the time. Good thought on it, but it doesn't work on every case. Loud. Okay, so how would you do that? Looking at what? That is a layer of security. It's valid, but it doesn't solve every case. For example, people tend to use the referrer header, but that's a privacy issue. I have a plugin that removes the referrer header. So that could be like an additional thing, but it won't fix every case. Are you the security guy of Whitelisting? No shorts for you. Okay, yeah, very, very smart, very good, very good. So CSRF tokens, and I finish with this, I promise. We include a random value in every request. Why do we do that? Because we want to validate that request on the server side. It's called a CSRF token. At least unique per session, because if you don't make it unique per session and it leaks, I can use it down the road, right? If it leaked somehow. Obviously, the attacker can't guess it, so it needs to be random and long. And use it to validate, as I said, the request. So this is how it usually looks like, a form, right, where I click transfer money. It will include usually a hidden input with the random token. That means when I request the page to transfer money, you create a response server side and include that token. Now, I cannot anymore, if you come to my malicious site, I know all this, but I don't know the random token, right? So I can force the victim to make the request, but by the time it gets to the server, you're gonna look at it, and the first thing you do is validate the token, and because I couldn't guess it, it won't go through. So you see the same thing here as a post request. So basically this, when you click transfer, it will just append the CSRF token, and that's the first thing you validate. That's how we fix it. So what happened? Listen to this. This story is very good. So this guy found indeed vulnerabilities that basically the control panel of, I think the Linksys routers, I don't remember anymore, were not CSRF protected. What does it mean? What can you do on the router? You can you can activate remote control. That from the internet, you can control your router. You can change password, your admin password. You can do a lot of stuff. So that wasn't CSRF protected. So this guy knew, okay, I can now force people to change their password and put my password and to check the remote access so I can control it remotely. But the smart thing of this guy, he was like, okay, but now I need victims coming to my site. So having people coming to my site that has that specific router is tough. So the guy was like, okay, I'm gonna go to the official. What do you do when you have a problem with your router? You go to the forum of that router. So that guy went there, found an XSS, and put the CSRF payload there. So every person that was coming to the forum was actually doing this request. So he compromised millions of routers, because obviously when you have a problem with that specific router, you go to the official forum. Very, very smart. And I will skip over this because we don't have a lot of time. We can talk about it over beers. And there is much more. There is tons of vulnerabilities that I don't have time. We can talk about it during beers, but I basically want to get you guys excited about this. So the takeaways here is think like a hacker. Think out of the box, right? It's very, very important, because many of these attacks that I tried to explain to you were like really edge cases, or people like thinking, how can I make this even more impactful, right? All user input is malicious. If there is one thing you want to take home, is apart from swag, is all user input is malicious. Add multiple layers of security, because you are going to fail at something, but if you have multiple layers, then the victim will hit a wall at some point before compromising your data. Follow standards, recommendations, and best practices. There is so much academia and so much forums and so much stuff that you can go read, learn, practice, and apply. But overall, just go and break stuff. That's the most important. I don't want to leave without giving you resources, because I really like that people goes out here and can go do more. Learn from free. That's what I did. SecurityTube has really good mega primers for free. Cybery website as well. Online university courses. I learned all the cryptography I know, and I could break LastPass thanks to this guy, to this PhD professor that is God in cryptography. I wish he was my friend. But I learned all the cryptography from that free. It's a standard, it's a Stanford course. In Udemy, you also find a lot of security courses. Read and practice. The Tangled Web, really good book, especially for JavaScript people. It tells you all the quirks and stuff, and you will be really fascinated by it. And if you want to go into like bug bounty stuff, the Web Application Hacker's Handbook, really good. Vulnerable websites, you can go and hack legally. I did that too. WebGo, Google Gruyere is really good. You don't have to install anything. So you go there and start to practice what I talk about today. Cross-site scripting, ZSurf, all that stuff. Join bug bounties, make money out of it. HackerOne, Backcrowd, Synac, all really good programs. You can go and hack legally. It's very, very cool. Thank you very much, guys. Appreciate it. So just like in Uber, please give me 5 stars. No, I'm just kidding. But there is a survey that you can go and do. I think it's incredible. The community here is fantastic to see so many people. First time for me in Guadalajara. Really, Whitelisting, what you guys are doing is incredible. I have only seen this in San Francisco, and they got a lot of money over there, and still not as cool as you guys here, having the pizza, just mingling with people. This is really awesome. So thank you, Whitelisting, for having me. Thank you guys for coming. There is some swag here. Whoever didn't get, come and grab it.
But don't rush us yet. Hold on. So he's given us all the swag. Can you grab my, yeah, don't touch. That was my wallet, okay. Since you're giving away all the swag, we wanted to get you officially Whitelisting swagged up. So now you can wear this around San Francisco and tell everybody about it. Thanks a lot.